Welcome everyone at this Cubics webinar. I hope you can hear and see us. Today we are going to introduce the basics of SQL language, the way relational database work, and how to write SQL queries. I am Alexandra Pro, software developer and Scrum Master at Evosoft, and I am going to be your host today. Cubics Institute of Technology gathers and provides the most needed building blocks of IT professional skill set, doing this by organizing online trainings mentored by industry experts and quality assured by industry-leading tech companies and higher education institutions. Today, we'll be assisted by Máté Farkas. Hello, Máté.
Hi everyone.
Máté is Microsoft Data Platform Consultant and Microsoft Authorized Trainer who has been working with database development for more than 15 years, 10 of which have been exclusively with SQL servers. Máté is also our SQL teacher at Cubics Institute of Technology. A few more operational details before we get started. You can ask questions at any time in the comments. All questions will be answered at the end of this webinar. And if you can stay for the end, you can watch the webinar back on Cubics Facebook and the YouTube pages. So if you haven't already, follow us on our social platforms. And now I pass the opportunity to Máté. Let's start the webinar.
Okay, thank you. Thank you very much for this introduction. And yes, today I will be your guide to this journey into the world of relational databases and the SQL language. This is a practice-oriented presentation. So there are some simple data queries which you can try out yourself if you want. So if you want to follow this session, then you can download a simple tool from Microsoft. That's a free tool. You don't need any administrative rights to install it because you don't need to install it. Just download a zip file and extract it and start it. I already downloaded it in advance. Alexandra, please share the link to the attendees where it can be downloaded, or an alternative way is to just type in the Google download Azure Data Studio. So if you do this,
Máté, I already put it in the comments, but do you want to share your screen with the viewers?
oh, sorry, I forgot to share my screen. Sorry. Yeah. Thank you. Okay. Now, do you see my screen now? Not yet. Share screen. This one. Okay, now here is better. All right. Do you see my screen now?
Yes, we can see your screen.
Okay, fine. Thanks. So I just typed in the Google that download Azure Data Studio, and the first Microsoft link, which is not sponsored, you can choose it. And here you can find some versions of this Data Studio for different platforms. So if somebody follow us from Linux or OS X from Macintosh or something else, then they can also download that version. Now we downloaded this zip version by this 64-bit link. This is what I did in advance. It's just a simple zip file. You can extract it. I already extracted to here, not yet, but now. So to here, see AMP Azure Data Studio, as you can see. Now I'm extracting. while you are downloading and while I'm extracting, I want to move on with this topic. So my name is Máté Farkas. Yes, I am a database developer for more than a decade, and I'm teaching SQL and relational databases for more than 5 years. So in this session, I will introduce you into the databases world and the SQL language. So these are our agenda for tonight. I want to show you the future of this technology, the future of databases, and which are the roles or the different positions available in this industry. And if we have enough time, I can answer your questions if you have any. So let's compare first the Excel and the databases, because sometimes some people think that the Excel is also a database, but it doesn't. It cannot achieve the requirements what is exist against a database. So for example, the first thing is that the Excel is only a single user data storage technology. If two people want to edit the data, you cannot do this. So only one user can open an Excel file and edit. Others can view the file, but cannot edit the data. However, the databases are designed especially to edit for more people at the same time. And the database server is aware not to overwrite each other's work inside the database. And there are many differences between Excel and databases. I don't want to explain all of them. Perhaps some more important. For example, in Excel, we can use up to 1 million rows in one table, while in databases, we can use theoretically infinite amount of data, infinite amount of rows. In some databases, we can have couple million or couple 100 million rows, even billion rows. It doesn't matter, because the databases are designed to use more data or more rows which can fit in the memory, which can fit in the server's memory. However, in case of Excel, we have to load the whole Excel file into the computer's memory. And if the computer has not enough memory, then you cannot open that Excel file if it's too huge. So here are some differences. Maybe the last one is more important, that the Excel file or the Excel based on a file share. So you should have, or you have to have a direct access to that Excel file on a disk or a file share. But in case of a database, you never can touch the database itself directly. You can just call a service at the database server, and the database server knows where are the data stored in the database, how it's stored, how it can be queried or read or write. And this ensures for us not to confuse the database file. So the database server manages the whole database file physically on the disks. So we cannot access the database directly, only the server. This is why it's a client-server architecture. So I am the client, and I'm connecting to a server and ask some questions from the server to get some data or to put some data into the database. These are the questions. Okay, so what is this client-server architecture? Imagine that we have an application on our computer. It can be an Excel or Access or any other applications. I put here some icons. Or it can be any application written by a developer in different programming languages like Python, C#, Java, or something like this. It doesn't matter. Somehow in this application, a data requirement appears, a data query somehow appears. It can be in a simple text box, in a text editor, where I can simply type the query, the data query. But sometimes the application is written that way that it can produce some data queries. These queries, these SQL queries, are translated by a driver, which should be installed on the computer, and it is sent out on the network, and on the other side of the network, there is the server, the database server, the SQL server in this case. And behind the SQL server, there are the databases. And my application wants to query some data from the database, so it connects to the database over the network, send the SQL commands to the SQL server. SQL server executes the query, gets the data from the database or databases, and sends back the result to my application, to my computer over the network. So this is how this client-server request and response technology work. So I never touch the database directly, as you can see on this image. I just query or send some requests to the server, and the server will serve my request, my questions to the databases. Okay, now let's see how the Azure Data Studio extraction looks like. This is it. So you can see here that I extracted into this folder ctemp Azure Data Studio, this zip file, and what we need is only this exe file, this Azure Data Studio. That's a simple application. Just double click and start it. You don't need administrator rights or any special application or installation. You will some pop windows displayed here by the X, closing it here, and I delete this connection. Okay, so this is, okay, I close and restart, just to have the initial state of this Azure Data Studio. Okay, restart. Some seconds. Okay, that's it. How Azure looks like. There is a welcome screen here. You can close it, and by this big blue button, new connection, you can add the new connection to the studio, and we have to define here some parameters to the server. because we will connect to a database server over the network, as I described in the presentation. So the data to connect to this database is here. I want to give it to you. Alexandra, I insert this information into the chat. Please please forward it to the attendees. So yeah, thank you. So here are the settings. Connection type is Microsoft SQL Server. Fine. The server is this mate-test-SQL Server database.windows.net. So just copy this server name and insert into this server field. The authentication type is SQL login. So just use SQL login. In this case, we have to define the username and password. Copy over the username, which is this one. Or you can just type course, if you like, this one. The password is the same, this one. Remember password, of course. And the database can be selected or typed. I will type top bike. This is the name of the database. Top bike here. Okay. If you fill everything this way, then just click on connect. And if we do everything the right way, then we can connect to this database. You can do it yourself. So this is how we could connect to the database. Over the network, moreover, over the internet, we connected to a database served in the cloud in Azure. But it doesn't matter, it's the same as we just connected into a SQL server, a local SQL server. Okay, so now we connected to the server, but before we jump into the SQL command, just a couple words about databases. So in the relational databases world, there are relations, there are connections between tables. In this example, you can see that the customer is not written in each line of the orders. This table is about the orders, which are typical orders and clients structure. So here you can see that what are ordered by these customers. So we don't write the name of the customer in each line, but we register the customers into a separate table with all the properties of that customer, like the name, the address, phone number, email address, tax number, and so on. And we give an ID for that client, and we just use this ID in the second table, in the orders table. This relation, this link between two tables makes the databases as relational databases. So this is the relation between tables. And this is a built-in functionality in relational databases. And the SQL Server tries to manages this relation that way that, for example, we cannot use a customer ID here before we register it into the primary table, in the customer table. and vice versa. So we cannot delete a customer from a customer table which has any order in the orders table, because if we could do this, sorry, if we could do this, then the structure of the database would be collapsed, and the database uh, could be in a corrupt state. So this is the relation between tables in case of databases. But what are the other properties and services of databases? For example, in databases, in relational databases, there are two-dimensional tables like in Excel. But in Excel, we don't have unique column names. Actually, there are no column names at all in Excel. We just put some names in the first row, but it's just the first row of the table, not the column header. So in relational databases, there are well-defined table structures with unique table names and unique column names. There are relations between the tables, of course. There are strong data types. We can use different data types like number, date, or floating numbers, or text, or some other data types. However, in Excel, we cannot use data types. We can just use formats, how to display the data, but that's not the data type. And some other services of the database, like we can define that a column is mandatory or optional. So you can leave a column empty if you don't want to fill that row, but you can enforce that a column must contain every time a valid value. So these are all the services, the functionalities of a relational database. And what is this SQL language, what we use to manage SQL data, relational databases? If we want to position this language in the world of computer languages, then it's in a separate family of languages like jQuery, XPath. These are the query languages. So this is important because if we write SQL queries, then we don't coding, we don't programming. It's not a programming language. You cannot create classic applications which have windows or text boxes or any input controls on the screen. If you want this kind of application, you have to use C# or Visual Basic or some other programming language. But the SQL is not a programming language. It's a query language which helps us to define a data request from a database or any other data storage. So on the screen, you can see a very simple SQL statement. There are some colors here, some words here, but it's a complete SQL command, and it can be executed in the SQL server. Let's try to reproduce this query and execute, because now we have a connection, a live connection to a database. Try to execute this query, because this query, this example is especially designed for this database, so it can be executed. I close this tab in Azure Data Studio and open a new one. You can open a new query window two ways. Just right-click on the database here and choose New Query in the local menu, or File menu and New Query. It doesn't matter which one you both ways, you will get an empty query window, which is actually a simple text editor. Here you can type anything in this window. Now let's type this query: select star from customer. Before I describe in detail what's are the meaning of what is the meaning of this query, just follow me in your computer. After you type this query, select star from customer, just hit the F5 key on the keyboard or click on this green run button. But I recommend you to use the F5 instead because it's more convenient. So if you do, then this tool sends this text to the SQL Server over the network. SQL Server executed this query and sent back the result us. And the Data Studio rendered this table on the bottom of the screen. Actually, this is the content of this customer table. Well, what are the tables in this database? On the left side, in this browser area, you can expand the tables folder. Here you can see what are the tables in this database. So we have this dbo.customer, which is the customer. Every table has this dbo prefix because it's a default grouping functionality inside the server, but it doesn't matter now for us. So this is a very basic SQL command which gets back all the rows and all the columns from this customer table. That's the customer table of this database, because this top-by database is a very simplified client and sales database. Contains orders of customers and product information and order details in these tables. Okay, so this query example looks a little bit different. So select first name, last name, city. So just change this star from this query. Select first name, but you can see that as I started to type this column name, this first name, Azure Data Studio immediately displayed a list of possible and available commands at this point, which is reasonable at this point. And the first name is already in the first row. I can move the selection by the up-down arrow keys on the keyboard. So after I select the proper item in the list, just hit Tab key on the keyboard. So first name, comma, space, last name. I don't finish the typing, just hit the tab, comma, and what was the last one? City. From customer, you can see that the customer is in a new line. Okay, let's do it in a new line. Where city in between brackets, I just type one city here, Chicago. Okay. If you finish typing, you can try the query in this state. Just press F5 again. Now you can see that the query executed again, but now we don't have all the columns from the customer table, only these 3 columns, last name, first name, and city, and we have only the customers from the city Chicago. If I want to do the same thing as in the example, then I can put another city name like Budapest in the list. Now I get back users from 2 cities. And finally, there is one more line, order by city, first name, last name. So if I want to order this result, then in the new line, I put here order by city, then last name, first name and last name. First name, last name. First name. Okay. Finally, this is the final result of this query example. I hope it works for you. As you can see, this SQL language and this query looks like a very, very simplified English sentence. So select something from something where this condition, order by this and this and this. And that's the main idea or the main concept of SQL language. When it was started in the 1960s, that this language should be very close to a human language, and this is why it is very similar to an English sentence. And because of this, there is a fixed word order like in English. So, for example, the select always must be in the first part of the query. The from always must be the second part. Where always must be after the from. The where, which is the filter of the query, cannot be before the from. Never, because it's incorrect. Let's try it. Move the where line from here before from. Let's try to execute it by pressing F5. Then I get back this error message from the SQL Server, incorrect syntax near the keyword from. So it doesn't work. The fixed word order is very important. You can see that I broke this code down to different sections. However, I could write this in a single line. This way it works perfectly because SQL Server doesn't care about the line breaks or the tabs or spaces. I can put any line breaks anywhere, any extra spaces or any line breaks. It works all the way. There are keywords and comments. So here you can see some keywords are highlighted by blue. That are the built-in fixed keywords of the SQL language. And you cannot use these words as object names like columns or tables. And the result is always a table, a two-dimensional table, nothing else. This is the main concept of relational databases and the SQL language. It always returns a table. It can happen that the table contains only one column or one row, but it's a table. Okay, that's a very basic introduction into the SQL language. You can try this query yourself if you want. Now I jump forward and I want to show you what are the different roles or the different positions in the database word. I just go forward. These are the different sub-languages or families of SQL, but you don't need them for the first step. You need only this first area, select. The select command is so complex and so much functionality that it can cover all the requests what we need in databases. All other commands are used to change the data structure or add new data or change existing data in the database. But these are very rare cases. Most of the cases we want to get back the data in different ways, with different calculations and for different purposes. So this is why the select statement is the most complex and the most productive command in SQL language. Yes. Here you can see the different positions. What you can see in different professional portals. For example, the database developer should know almost all the families of SQL language. But a simple report developer or data analyst is enough to know a SQL command, a select command, or insert, update, delete, merge commands. But the select is the most important. And finally, there are database administrators who never change data in the database or never select, or they never create reports, but they manages the database, so they need another set of SQL commands. Let's move forward, because this is about the fixed word order, but I already described this for you. Let's go here. Start from here, slideshow from here. So these are the different professions. There are two main areas of SQL and relational databases. One is database administration, and the second is database development. Here you can see some different skills and tasks, what are done by database administrator. The most important is security backups and restore strategies, and implement security settings in the databases, and so on. Here you can see many tasks which are done by the database administrators. That's one area. You don't need to know too much SQL commands to do this job, but you have to know many aspects of databases, the server, the hardware, the network, and so on. So that's a typical administrative work. Sometimes the system administrators do this work in many companies. And another area is a database development. This is a completely different role, but it also uses SQL and relational databases. Here you have to create databases, tables inside databases. You have to create data modification queries, data retrieval queries, and many other tasks. Sometimes you need to import data from external sources, and all these tasks can be done by SQL commands, only SQL commands, because there are no other way to manage anything inside a relational database, only by SQL command. There is no other tricky way or secret way to connect to a database or a server and send some commands and do something. Only SQL commands. But you can do everything by SQL commands. Even you can shut down a SQL server by a SQL command. Okay, let's move on. How much time do we have? Couple minutes. Okay,
Around
then let's.
10 minutes left.
Sorry, again?
Sorry, around 10 minutes left.
Okay, thanks. Okay, so what are the futures of database technologies? Here you can see a very simple comparison. Today, the cloud-based databases are becoming more and more important. This in slideshow. Okay. So yeah. Okay, so the cloud-based database is a database server or a database which is served not locally on our network or the company's network, but it is hosted by a third-party company or a service provider somewhere in the internet, and we can connect to that database over the internet. So that's the difference between the cloud and on-premise databases. If we use a cloud-based database, then we don't have direct connection to that database, to that server. In this case, we don't have access, a physical access or a physical connection to the server itself, but we don't need it because the administration and the operation of these databases and servers is someone else's task, not our. This is the main advantage of cloud-based databases. Then we don't have to pay for database administrators or system administrators or DevOps. It is managed and secured by another company. Of course, we have to pay for that, but that expense can be much lower than if we would operate those servers and those databases locally in our infrastructure, because operating a local infrastructures needs a high amount of resources. For example, power, you need air conditioning, you need redundancy for power and the network and storage and so on. And these are huge expenses. And these expenses, and of course we have human expenses because we need administrators which can operate these infrastructure. So these expenses are higher than we just order or provision service, for example, a database service from a cloud, from a service provider. So there is no administration and maintenance and costs, of course. The redundancy is automatically built in these systems. So if there is a catastrophe or any disaster at the data center, then another data center can automatically take over the work and can continue. We can continue our business. Network and computing redundancy is also built in, and storage, of course. and it's possible to build up a geo-replication very easy way. So for example, if I want to replicate the data to another part or another end of the world, for example, from Europe to United States, then it can be achieved by some simple clicks. However, in a real world, it's a very hard task and very hard work to build up this kind of data synchronization between continents. There are different service levels. I will show you shortly this one. And of course, we know what we want, what we have to do if we operate a database or a server locally. All the tasks are ours. We have to do everything, and we have to pay all the costs locally. Okay, so what are these service levels in the cloud? The first level is a simple virtual machine, and this virtual machine runs a database server and serves some databases. Another level is we use a SQL managed instance, which is a SQL server, but not on a virtual server. We don't have access to the virtual server or the virtual machine itself, only to the SQL server and the databases, of course. And finally, the highest level of the service is that when we don't have access to the SQL server itself, only to a database. So we have only a database endpoint, and this way we can just simply send SQL queries into that server and get back the result. But we cannot do, and we don't have to do any maintenance, any other operations on that infrastructure. This is the way how we connect it to this database by the Azure Data Studio. So this top bike database is this level, what you can see here. So we don't manage the SQL server, we don't manage the virtual machine under the SQL server, we just use the database service. Okay, so here you can see the cloud, the different service levels as I described, from virtual machines to the simple single database service level. So this is the future. If you want to ask me what is the future of databases and the SQL language, that everything goes into the cloud because the costs are lower, the maintenance tasks and the risks are lower, and you don't need so many skills and so many experts to operate the infrastructure. Okay, that would be my part. So if you have any questions.
Thank you, Máté. I have. The first one is, will you cover window functions during the course?
Oh, that's a very good question. Yes, but the simple answer is yes, but we have two sections of this course, and actually that's two separate courses. There is a very basic course which starts from the beginning. This is good for anybody who hasn't worked with SQL at all. So it starts from the beginning. The requirement is just to know what is the data and know the Excel, and that's all. In this first course, this takes 4 weeks. we don't touch the windowing function, but in the second part, that's the intermediate level of SQL queries. We use all different type of windowing functions, so aggregate functions, windowing, and so on. So unfortunately, the first part, what will start next week or in 2 weeks,
26th of April.
26th of April, we will not cover windowing functions. But this course has live consultations in each week. So 4 times we will have 1 hour. And if you want me, I can describe some functionalities of windowing functions, even if the course material doesn't cover it. So this is the advantage of this type of course and this model what we use at the cubics, because you just don't you have a video material, but once a week for 1 hour you can meet me and ask me anything, really anything, not just related to the course material, but anything. And if you ask me about windowing function, of course, I will show you windowing functions.
Thank you, Máté. The next one is in the presentation, there were relatively shorter queries. Is it the best practice to have lots of small ones, or the more complex a query, the longer it will be?
Actually, not. So not. This is not the practice. But we always start from small queries. As you could see, we started from select star from customer, and then we expanded that query, and then we expand again, and then we rewrote other parts of the query. So this is how this work look like. We always extending and changing the code, and the SQL query becomes bigger and bigger and more complex. And finally, it could be 100-line long SQL query. So somehow we have to start, but usually queries are not so simple, because sometimes or in many cases, the queries are not simple. So if somebody wants you to just list all the customers at the company, of course, it's a simple query, but I have never heard this kind of simple query. So that's.
Thank you, Máté. Unfortunately, our time is up. Just one more thing I want to share with you. Our SQL course will start at the 26th of April, where you can learn from Máté essential skills to expertly navigate relational databases, master a wide range of queries, and advanced SQL techniques. And if you are more interested in the world of development, follow Cubics on our social media platforms and don't miss our upcoming events. And thank you for joining us, and thank you, Máté, this interesting presentation and live demo.
Yeah, and see you on the course. Bye.
Yes, bye.